Taking a look at section 1.8 dealing with inverse functions. You have this outline given to you, so you already know what the objectives are, so we'll go through this pretty quickly. We will be verifying inverse functions, which are functions that are similar to the function that we're given, but slightly different. They have a correlation between them, so we'll see that. We'll find the inverse of a function, use the horizontal line test a little bit, not so much though. Use the graph of a one-to-one function graph to see its inverse function. Also finding the inverse of a function and graphing both functions on the same axis, or axes. This will be for problem 4. So the steps that are given here can be a little tricky to understand, but really the main area to follow through with for this class is just going to be that normally we're always solving for x, and really that's the case here. So when we solve and we find inverses, the way that we go about finding the actual inverse of a function is by changing f of x to y. We then switch x into y, and then we solve for y, which can be a little tricky, but I'll guide you through the first one. So following through with the steps, I'm changing f of x to y and rewriting this. So instead of f of x equals 2x minus 5, I'm writing y equals 2x minus 5. So this is considered step 2. Switching x and y. So what does that mean? Instead of y, I'm now writing x. Instead of x, I'm now writing y. So this is step 3 being used here. Step 4 has us solving for y. So what does that mean? We're isolating y. So if we try to isolate this y variable, we can add 5 to both sides. We can add that to x. So on the left side, we have x plus 5 equals 2y. We can take this further, dividing both sides by 2 because we want to try and isolate y. 2's cancel. So this leaves us with y equals x plus 5 over 2. And if you want to rewrite this using 2 fractions, you could say something to the effect of x over 2 plus 5 halves. And then it says change y back to f inverse of x. So this is equal to f negative 1 of x. So f inverse of x. Both of these are fair game. They could both be written and interpreted the same way. We see the same idea here. If you want to pause this, give this one a shot, go for it. But I'll quickly go through this one. So if we follow through, we have y equals 1/2 x minus 4. If we switch these terms around to y, solving for y now, we have x plus 4 equals 1/2 y. We can get rid of this fraction by multiplying both sides by 2. So when we redo this, our 2's cancel. This leaves us with 2 parentheses x plus 4, which you could rewrite by distribution to 2x plus 8. And this equals f inverse of x. So we got those. For the next problem, we have a composition of functions again. As mentioned in class, when we deal with these, our goal is to really kind of look in. So the one meme that's on the board has the egg toys from Toy Story that kind of hop out of each other in the very first film. And so if you recall this, the main thing is that we're trying to look towards the middle. So let's refresh ourselves on that. So we're trying to start with the middle term. And the middle term in particular, what does that mean? Well, we have these 3 functions, f of x, g of x, h of x, that are composed in each other. So how I personally rewrite this would be something to this effect, where we have h on the outside. We're then taking some function with g, but in the way middle, we're evaluating f of 1. And they're asking us to do this without writing an equation for the function. So if I start with the very middle term, the middle term I see is f of 1. So f of 1, that's pretty easy to solve for. On the side here, I'll show that. So if we're getting f of 1, This equals 3 times 1 plus 4. Again, I'm getting this based off of f of x, which was given. So this gets us an outcome of 7. I can then rewrite this and say that instead of f of 1, this was 7. So now I'm being asked to find g of 7. So if we get g of 7, this equals 2 times 7 minus 1, which is 13. Lucky 13. And then if we build out the rest of this, instead of g of 7, we now want to write 13. So notice that we had to kind of build this sequentially. We couldn't just start with the outside and work our way in. We had to find some value in the middle and work our way out. So h of 13 would look something like this. What's originally x squared minus 2x plus 5. If you're evaluating h of 13, you're evaluating 13 squared minus 2 times 13 plus 5. I already know the arithmetic for this. This would give you 148. And the reason that they want you to evaluate this without finding an equation is because if you actually do something like that, it would look something like this. You have that, and then you would have that around here, and then all of this being squared minus 2 of all of this, and then eventually adding 5. So it's a lot easier to just work from the middle out. That's why they mentioned don't write an equation for it. Using interval notation, finally, giving the domain and range of f and f inverse of f. Well, this is pretty easy to go with. If we rewrite f of x, following through with the steps on the first page, we can rewrite this and say it's y equals x cubed minus 8. We can then switch our terms, which is dealing with, I think, step 2. So we now have x equals y cubed minus 8. If we solve for x, if we add 8 to both sides, this leaves us with x plus 8 equals y cubed. How can we get rid of this 3? If it's an exponent with 3, how can we get rid of that? Well, think, if we were taking y squared equals something, how do we get rid of the 2? In this case, we can take what they call a cubed root. So we're taking all of this with the root of 3. And then we'll see that now, and I'm going to rewrite this just as f inverse of x. F inverse of x now equals the cubed root of x plus 8. And so the domain and range we've talked about for previous sections. That's just saying that the domain or the x values that are used with the equation. Range deals with the y values. Using a graphing calculator for this will be helpful, so I do that. So the two functions I'm going to graph out, first is going to be x cubed minus 8, because they ask us to evaluate for both f and f inverse. So if we graph x cubed minus 8, I can zoom out a little bit. We see that this is most likely going to be continuing, so all x values are fair game, all y values are fair game. So if we switch back, we can say that for f of x, the domain is all real. So from negative infinity to positive infinity, along with the range. And if we graph out f inverse, we'll see what's up with that. So again, a graphing calculator can really help you out here. If you're using Desmos, that's another substitute. So if we switch this, so although I have this all to the 1/3 power, I could have also rewritten this. I think it's tricky how you have to get to it. I think it's something like cubed root, which is all the way down here. There we go. So this is going to give us the cubed root of x plus 8. Of course, only 1x. This will actually give us the same one. So these are two of the same ways you can interpret the same kind of function when you're graphing these. This is channeling a little bit of algebra 2. But if we look at these lines, it looks as if all of the x values are fair game. We can assume that all of the y values are going to continue and continue upwards with nothing different. So we could say that for this one, it's all real numbers as well. So we can say the same. Notice that we had to graph these, which is okay. Desmos can help us out. If you have any questions, email me or bring them to class.